Alright, we're going to finish up this last video here, which should be the last video for not only section 7.5 but for chapter 7. What a wonderful, weird road it's been. Alright, we're going to finish off. We've been talking about how vectors can be used to compute work. We're going to give the definition of work. Work, if the displacement vector d is the displacement vector of an object on moving the object in a straight line from points A to B under a constant force F, then the work W is done is computed by taking the vector F with the dot product here of, with the dot product here of the displacement vector. Almost messed that up. So now, that's if it's on a straight line. If we have an angle here where the force is being pulled at, like the rope pulling the object, we can find that by taking the projection of vector F on D, so that it's that only in that direction, times the absolute value of the displacement here, which we can compute this way. The absolute value, I shouldn't say absolute value, but the magnitude of vector F times the magnitude of vector D cosine of theta, where theta is the angle between vectors F and D. So the first one we're going to have in a straight line here. It says if the work done by a force, and this is the vector here for the force, 2I times vector I plus 7 times vector J, which is in newtons, is moving along an object in a straight line from point A, which is at -1,5, to point B, which is at 9,11. Let's assume that the units in the coordinate plane are meters, so we can have Newton meters here. First things first, we need the displacement vector. So we're going from A to B, so that would be vector AB, which is kind of like B minus A, so it would be 911 minus -1,5, which would give me vector 10, 6. Now, the work is equal to the force, which is vector 2, 7, dot product with vector 10, 6. So that's going to be 2 times 10 plus 7 times 6. 20 and 42, that's 62, and that would be Newton meters. I think there's a dash in between there, Newton meters there. And that would be the amount of work that it would take to move that object using that force. Now let's change it a little bit. Let's say we've got a dog that's pulling a sled. It's kind of apropos in a weird way because the Iditarod is going on right now. And the guy that was in the lead lost the lead because the dogs went home. They wouldn't work with him. So a dog pulls a sled 200 feet across the yard on a horizontal path. Alright, this dog exerts, I've got she, so I guess it's a female dog. She exerts a constant force of 25 pounds directly upward at 15 degrees from the horizontal. That's to indicate this. Alright, we're to find the work done. Well, to find the work, I'm sorry, I'm right in the way. By the way, this is my sled here, and it's going in this direction. Here's your displacement, here's your force here. So W would be equal to the projection of our displacement of our force here times the magnitude of the displacement, which is going to be the magnitude of the force times the magnitude of the displacement times the cosine of 15 degrees. Well, let's see. The magnitude of the displacement is 200. The force is 25. So this is 25 times 200 times the cosine of 15 degrees. Now, I don't know what the cosine of 15 degrees is off the top of my head, but, and I left my calculator at my desk, so I'm going to have to check my paper. And according to my paper, the cosine of 15 degrees times 25 times 200 turns out to be approximately 4830. And this would be in foot-pounds. So, find the work done. The work done by the dog pulling the sled is 4,830, this is to the nearest whole number, I didn't write it down, but I'm pretty sure it's to the nearest whole number since it's irrational. 430 foot-pounds. And that's the answer there. So this was short and sweet, but it finishes a really important chapter. If you think back to where we began in chapter 7, with the idea of polar coordinates and polar equations and all the stuff that we've done with vectors, a lot of good information in this chapter to go back and maybe refresh your memory of before you get around to taking the chapter test. All right, remember, practice, practice, practice.